Bismillahirrahmanirrahim. Assalamu alaikum. Today my topic gravitational potential. In classical mechanics, the gravitational potential at point in space is equal to the work energy transfer per unit mass that would be needed to move an object to that point from a fixed reference point. It is analogous to the electrical potential with mass playing the role of charge. The reference point where to the potential is zero, is by convention infinitely far away from any mass, resulting in a negative potential at my finite distance. Plot of two-dimensional slice of the gravitational potential in land around a uniform spherical body. The inflection points of the cross section are at the surface of the body. In mathematics, the gravitational potential is also known as the Newton's potential and is fundamental in the steady potential theory. It may also be used for solving the electrostatic and magnetostatic fields generated by uniformly charged or polarized ellipsoidal bodies. Potential energy. The gravitational potential V at a location is the gravitational potential energy U at that location per unit mass. V is equal to U by M, where M is the mass of the object. Potential energy is equal in magnitude but negative to the work done by the gravitational field, moving a body to its given position in space. From infinity. If the body has mass of 1 assigned of kilogram, then potential energy to be assigned to that body is equal to the gravitational potential. So the potential can be interpreted as the negative of the work done by the gravitational field moving a unit mass in form infinity. In some situations, the equations can be simplified by assuming a field that is nearly independent of position. For instance, in a region close to the surface of the Earth, the gravitational acceleration g can be considered constant. In that case, the difference in potential energy from one height to another. It's a good approximately linearly related to the difference in height. Mathematical form. The gravitational potential V at a distance x from a point mass of mass m can be defined as the work that needs to be done by an external agents to bring unit mass in form infinity to that point, where Vx is equal to Wm is equal to 1m x f dx 1 over m, where g is the gravitational constant and f is the gravitational force. The product gm is the standard gravitational parameter and is often known to higher precision than g or m separately. The potential has unit of energy for masses. Example g kg in the MKS system. By convection, it is always to negative where it is defined and as x tends to infinity it approaches zeros. The gravitational field and thus the acceleration of a small body in the space around the massive object is the negative gradient of the gravitational potential. Thus, the negative of a negative gradient yields positive acceleration toward a massive object because the potential has no angular components. Its gradient is shukriya. Wassalam.